cannot stain those particles with your acid and aniline dye stain. No. Simply as I've stated 1,000 times, that the particles are smaller than the molecular portions or the granular structure of your acid and aniline dye stain, so the mousey can't swallow the elephant. Naturally, they can only be stained with a frequency of light. You use a monochromatic light because the monochromatic light is a portion of the spectrum.
So when you get light in the same range or a corresponding range, it will cause those microorganisms to fluoresce. That's something that people hadn't really done before or since. Use monochromatic light to investigate microorganisms and determine species specificity, a specific species of a microorganism. One of the other working principles about it was that the way that it channels the light never allows the beams of light to cross over themselves and create diffusion of the light. So you continue to have your resolution no matter how far you take the light path. You're not losing resolution.
Well, the key features of the Rife virus microscope is that they had superior magnification with corresponding resolution, and also another important factor was the contrast that with his special illumination system he was able to produce contrast in the organisms without chemical stains. And even when identifying the organisms, because of the way they're illuminating and the contrast that's produced with the so-called monochromatic light, you could identify which virus you're looking at by the color that it refracted. So that had never been done and probably still hasn't been done today. And so these key features of the microscope, which were far superior to what was available at the time, allowed him to discover things that other people were unable to because they simply lacked the equipment.
Yes, John, we have taken those pinpoint cells, or what's known as the needle point cells of pathology, and we have separated those down 14 times, and bringing the instrument clear up to 50,000 times magnification. We have photographs of those that will show that the tiny cell is composed of a series of little cells. And the little cells, again, on a higher magnification, so we bring it to 5,000 times. At 10,000 times, we see that the cells within the cells are composed of a series of little cells. Then, we bring it on up, and we separate it down, and we keep that little point going up, as I say, to 60,000 times, and we wonder where infinity is.